In this problem, we're told that JKLM and PQRS are squares, and we're given that JKLM is similar to PQRS, and we're asked to describe a sequence of a rigid motion followed by a dilation with the center 0, 0 that maps JKLM to square PQRS. All right, what does this all mean? This means that we want to move this square down here somewhere in this quadrant and blow it up so that it will map to this larger square. So the first thing I'm going to do is I am going to put in my dilation line. That center of dilation is around 0, 0, and I can see that it lines up nicely with point P, and I kind of cheated a little and sort of made a pre-line to kind of speed things along. So now I'm just going to sort of darken it. All right, I need to get a point that's on this square onto this line, all right, one of these vertices. And I notice that there is another line here. I'm thinking that this is going to be a reflection because I'm looking here and I can see that the distance between these 2 points, for instance, is 1 from the line, this line, y equals 1. And I just kind of suss that out visually looking at this. So I'm thinking that if I can reflect across this line y equals 1, one of the points on this square will end up on this line. And I'm thinking it's going to be point J because I need to move down a fair bit. And remember, when I'm reflecting across a horizontal line, the only thing that changes is the y values, right? The x values stay in the same place. I'm basically just taking this whole square and sliding it down. And I'm sliding it across this line, or, pardon me, reflecting it across this line, y equals 1. All right, so let's see. How far is j from y equals 1? It is 1, 2, 3 units. All right, let's go 3 units below this line and see where I end up. 1, 2, 3. All right, so this point would then be J prime. And that means that I would have a point on this square here, on that line of dilation, okay, on that center of dilation. Great, so then first thing I can say is that my first step would be to reflect, pardon me, hopefully you can see this okay, reflect across y equals 1. All right, once I've done that, I want to blow the square up. So let's see what the relationship is. Let's see what the sides are. We're already told they're similar, so I know these sides are proportional. The side JK is 1, 2 units. And so if JK, let's see, can we do that? Yeah, JK is 2 units. Let's see how much larger is QP. 1, 2, 3, 4, 5, 6. That's 6 units for QP. And I'm going to tell you right now, I've just made a mistake. These should be reversed because I'm going from this one to this one. And I should be thinking of it in those terms because I know this is going to be an enlargement. So I'm going to switch these around. I'm going to write it as QP is 6 and JK is 2, which means K, my scale factor here, is going to equal 3. In other words, pardon me, every side on the larger square is 3 times as large as it is on the smaller square. So I can say that this would be a dilation of 3. All right, and we can check that. Why don't we try another side? Why don't we try KL? That's 1, 2 units, then this should be 6 units. 1, 2, 3, 4, 5, 6 units. And I am confident that that is correct. So what are the series of rigid motions I would use? Or a rigid motion would be a reflection across the line y equals 1, and then a dilation with a scale factor of 3.